Well, hello guys and welcome back to Mr. G Physics. This is Mr. G and this time we're going to be doing another question for the grade 11s. The grade 11 is about to write and we're going to do a question on electrostatic. This one is about the electric field, which could be tricky guys and it's important for grade 12. Don't go, subscribe for the channel, like the video, and we'll be back in diving into the question into a minute. Now we're going to dive into the question. This was question 7 done in Gauteng province in 2023. It's a good question. It's related to electric field, which is a very important part of the work. We answer almost all the questions in that question paper of 2023. The question says P is a point 1,5 meter from a charge Q, sphere Q. And I want to speak about that point real fast. That is a point. So these points don't have charges, all right? So that is an important thing to know. The electric field at point P is 6 times 10 to the 7 Newton per Coulomb directed towards Q. Let's speak about the electric field quickly. It's an important point here. Now, electric field, the symbol is capital E with an arrow on top because it is a vector. As a vector, it means it has direction. It have direction. All right, now the direction of the electric field will be taken as if in that specific point you place a positive charge. It is not a charge, it's a point, but the direction is going to be taken as if in that specific point you place a positive charge. So that is an important point here. So let's write here, this one is electric field at a point. All right, it is by definition equal to force per unit positive charge placed at that point. This one here is the definition. This is force per unit positive. That is what I'm just saying. That point is not a charge, but it's taken like if you place a positive charge. Positive charge at that point. Guys, this formula is the definition for electric field at a point. I think I cover now electric field at a point. If the electric field is a not uniform electric field, if it's not uniform, then we may use the formula is equal to K multiplied by the charge, not the charge of the point, the charge that is close or is producing this electric field, divided by distance squared. This one is if the electric field is not uniform, which is the case. This is not non-uniform. Let me just fix this one, guys. Non-uniform. All right, which is the same. We're going to use either formula. It depends on the question. So this is an important point to mention. And then here we can write the data. We have that the electric field is equal to 6 times 10 to the 7 Newton per Coulomb toward, the say is towards Q. Towards Q. That means that Q is a negative charge. So also extremely important. This Q is a negative charge. P is not a charge, it's a point. So if you have to draw graphically the electric field on P, then you will have to draw a vector. And then for this one, guys, I am going to use a different color. I don't want to take that color there. I want to get these colors here. So I'm going to use a different color. This is how you would draw the electric field at P. It is E. And it's towards Q because Q is a negative charge. Define the term electric field at a point. And guys, we already answered that one. It is here. And I want to point out once more that definition is not other thing than this specific formula that you have here. That is the definition for electric field at a point and it's given to you 2 marks for that one. You have to just be able to read. And an important point that is a positive charge. If you don't say the positive charge, you will lose the mark. Draw the electric field pattern caused by the charge sphere Q. Note, it is not the electric field for two charges, it's for only one charge. Once more, and I cannot stress enough, P is not a charge, it's a point. So let's draw the electric field pattern for a Q. And I think there's enough space to do it here. It's quite simple, and this one I'm going to do it on this side here. This one is going to be charge Q. Remember, it's a negative charge. Maybe I can just do it a little bit up here. There is a negative charge. How do we know it's negative? Because of the direction of the electric field at P. So if it's a negative charge, all the lines are going to be, now this one have to do nothing to do with negative or positive. Always, all the lines are radial out of the specific charge you're drawing. So they straight lines, no curve. I've seen nice funny curve and it's not curve, it's only one charge. So all these lines are going to be straight in this specific way. So you'll get 1 mark for doing this one in that way. They're supposed to be perpendicular to the surface of the sphere of the charge you're drawing, but it's fine. Now here the direction, if it's a negative charge, which is the case, the direction is towards. That is by convention. So it is toward the charge. If it was positive, then it was exactly the same, but going out of the charge. So guys, this one is question 7.2. If it was a positive, we can do it a very small example here. There is not like that, not like that either. It's going to be the same, but going out of the charge. Now, let me tell you something important. The more lines you draw, the more probability of making mistakes. So please, you don't have to draw 100 lines. With few lines will be enough to draw a nice pattern here. Now, question 7.3, calculate the magnitude of the charge on sphere Q. Guys, we're going to use the formula that we have here for a non-uniform electric field. We can do it on this point here. This one is question 7.3. It's quite simple, 7.3. And then electric field at that point is equal to K multiplied by Q divided by the distance squared. All right, so the data, we have the data, we can write it real fast here. I like to write data. So we have that the electric field, we are going to rewrite it. It is 6 times 10 to the 7. It's 6 times 10 to the 7 Newton per coulomb. We have K, which is 9 times 10 to the 9. You do not have to write the unit here. It's a long unit for that one. It's 1,5 meters. The distance is equal to 1,5 meters. You're looking for charge, and this one is everything. So all you have to do is to write the formula and substitute. So the formula is E equal to K. I'm going to rewrite it. Q divided by distance squared. Now, I personally like to substitute in the same way as the formulas are. Do not rearrange, because if you make a mistake, you lose the marks. So E is 6 times 10 to the 7. Now, note here, in this case, you do not substitute charges, the signs, etc. Not for this formula. This is a scalar formula, so everything in this formula is going to be positive, and then direction you will get it differently. So here, this is equal to 9 times 10 to the 9 multiplied by Q divided by the distance, which is 1,5 squared. And the rest is calculation. Now you may rearrange, but already you got 2 marks. That's why I say do not rearrange, rather do it at the end. So now here, if you rearrange, guys, you will get that K is equal to 6 times 10 to the 7 times 1,5 squared divided by 9 times 10 to the 9. And now I'm going to use my calculator right away. I have it here. 6 times 10 to the 7. Quickly doing the calculation, times 1,5 square divided by 9 times 10 to the 9. Guys, I'll get that is 0,015 coulombs. Now, the charge I get here is equal to 0,015 coulomb. That is the charge I got. You can write it in scientific notation. It's not needed. That is my answer, guys. I hope you get the same answer. Well, now, question 7.4 say another charge sphere are having an excess of 105. No, this is a mistake here. I make a mistake with the typing. I copy the question and I always retype it. So this is not 105, but rather 10 to the 5. This one is 10 to the 5 electrons. Is now placed 0.75 meter to the right of sphere Q. Now let's speak about this real fast regarding the question. I'm happy I actually typed the question. Now this means that this is another negative charge because it has an excess of electron. If you have an excess of electron, it means it's a negative charge. So in this case, we need to calculate the charge. Now, how do we calculate the charge? We're going to charge quantization. So this one, for this specific point, which I'm going to do it here, the charge is going to be equal to the number of electron multiplied by the charge of the electron. That is how do we calculate that charge, which we don't know what is the charge. We only know that have so many excess or extra electrons. So if we substitute here, we have 10 to the 5 times 1,6 times 10 to the minus 19. This one is the charge of electron, and with this one we'll calculate the charge of sphere R. All right, so now Q here for R is going to be equal to, if I do my calculation, 10 to the 5 multiplied by 1,6 times 10 to the minus 19, we get 1,6 times 10 to the minus 14 coulombs. This is the charge of that sphere R because of the excess of electrons here. All right? So now here, note that that sphere R is also negative. How do we know that, guys? Because it has an excess of electrons. It has an excess of electrons there. So we have Q, which is negative. We have R, which is negative. So now, to calculate the net electric field strength at point P, we also need the direction because it's a vector quantity. So you need to know that on P, there are two electric fields. There's one due to Q, which is pointing to the right, and this red color here is EQ, which we also calculated, and there is also ER, which is also negative, so it's going to be also pointing to the right. This one is ER, is also to the right. So at the end, you have to add the two electric fields. So now, how do we calculate the net electric field? Let's write it down here. E net is equal to EQ plus ER. That is taking, let's say, right as positive, and then the two of them are positive because the two of them are pointing to the right. So this, how do we calculate the E net? So we can actually do it down here in this specific space, new page. So this one is question 7.4. Let's do it real fast. This is 7.4. We have that E net. Now, a vector addition should be EQ plus ER. That is the vector addition. Now, after this one, you should say, right is positive. I don't know why I erased that one by mistake. That's supposed to be said here. Right is positive. Then, because the two of them are pointing to the right, for example, then we have that E net is equal to EQ, which we already know, plus ER. Now, ER is the one we don't know. We don't know ER. We can calculate it if you want, guys. It's KQR divided by distance square. So, in fact, we are going to do it here. K is 9 times 10 to the 9. The charge we just calculated with the excess of electrons, which is 1,6 times 10 to the minus 14, is 1,6 times 10 to the minus 14, and the distance square, let's go to the distance because we are from R. So the distance is 0,75 is all the distance from here to there, to that point, is 0,75 plus 1,5. So if we go here is 0,75 plus 1,5, everything squared. That is ER. So when you substitute, when you calculate, I'm going to do it real fast here, guys. 9 times 10 to the 9 times 1,6 times 10 to the minus 14 divided by, and now we have 0,75 plus 1,5 squared. you get that the electric field, and I need the scientific notation for this one, you get that is 2,84 times 10 to the minus 5 Newton per coulomb. So when you substitute here, now you can come and substitute that place there. If you want, you can try the formula there and maybe less steps. So E net is equal to EK, which we already calculated previously, and it was, or it's given to us. We didn't calculate it, it's given to us. Is 6 times 10 to the 7. This one is 6 times 10 to the 7 plus 2,84 times 10 to the minus 5. Then E net is going to be equal to 6 times 10 to the 7 plus 2,84 times 10 to the minus 5. And then, guys, the answer is 6 times 10 to the 7 Newton per coulomb. Now, what is the direction? Well, we got a positive answer. We say positive is to the right. So it is to the right. Now, in this question, they actually don't use right and left. So it should be actually towards the charges. That should be the correct direction. Guys, that is the answer. The marking wise here is going to be 5 marks for this one. So let's see how can we give marks here. It would be 1 for this one, 1 for adding, 1, 2, 3, 4, and then the 5 ones, guys, it should be for this formula once more. Guys, this is the answer of this specific question. I hope it helped. It's a good question. When I went to the memo, there was issue there. So I hope it helped. Thank you for watching. Subscribe for the channel. Thumb up, Mr. G.